Today we are discussing about operating system structures. There are three types of operating system structures we are going to discuss. First one, monolithic structure. Second one, layer structure. Third one, microkernel structure. In monolithic structure, we will discuss about two operating systems. First one, Microsoft disk operating system. Second one, traditional Unix operating system. But let's see Microsoft disk operating system structure. In Microsoft disk operating system, you can see there are four things here: application programs and RAM, BIOS, device drivers. These application programs are used by user to access this particular hardware resources. Okay, so let's see the properties of this particular MS DOS. One first and foremost thing we need to remember that it does not have a well defined structure. It does not have well defined structure because it was started as a small project and with limited systems, and as its popularity grows, it grows beyond its scope. Okay, this is implemented by Microsoft. And one more thing is that here the series of interfaces, there is different interfaces, and the functionality of each interface and functionalities are not well separated because they keep on adding one functionality after other, one functionality after other. They are unable to separate all the functionalities. Okay, and moreover, the biggest problem with this particular structure is the application programs can directly access the hardware by writing IO routines. So this leaves the system vulnerable to malicious user. What is malicious users? They can write some programs or IO programs, and they can access this particular hardware. That what is your hardware, such as your disks, okay, hard disk and etc. They can either steal the data or they completely corrupt the entire operating system, making the system to be crash. So this is the biggest problem. What is the biggest problem? The application programs can directly access the hardware by writing some writing some IO routines that leaves the system vulnerable to malicious users. Next, let's go to Unix operating system. This traditional Unix operating system, you can see that the structuring is very much limited. Okay, so it was limited by its hardware functionality. First one, the limited limitations is its structuring and its hardware functionality. It is not completely layered structure. It is simply only few layers will be there. Okay, and we can see there are series of interfaces, that is system call interface and kernel interface. System call interface is placed in between your kernel and system programs. What are these different system programs here? The shells, okay, is your interface. Shell is your interface, that is your command line interface, and in this particular shells you can write some commands, that is open, close, mkdir, rmdir, etc., so that you can access the hardware resources. You can access the hardware resources, but you cannot directly access the hardware resources here as you access in MS DOS. Here, in between your system programs and kernel, there is an interface called system call interface. What are the commands that you have typed that has to be compiled and interpreted by using interpreted, and they have to go to kernel program through your system call interface. And in kernel, all the core functionalities of the system is written in the kernel program, that is implemented in kernel program. What are major functionalities? The core functionalities will be one, CPU scheduling, that is this one process that comes under process management, and inter-process communication, and memory management that comes under page replacement, demand paging, and virtual memory. Okay, and IO management, that is IO, it has to manage all IO resources, so disk and tape drives. Okay, so these are all IO resources. All these are written, that is implemented in your kernel portion, okay, kernel layer. Then after this one, in between kernel and hardware, you can have a kernel interface. They implemented a kernel interface, okay. But the problem here is, look at all these functionalities, all of them has been implemented in a single program called kernel, single layer called kernel. Any changes, any modification in any, even one line of modification, you need to compile, recompile the entire kernel. And if you want to add any functionality, new functionality such as X, then you have to again recompile it, again recompile it. So construction, that is adding a new feature or new functionality, is difficult. Also maintenance is also difficult, because if there is any small bug, small error, okay, then you need to find that error. Finding the errors, because finding the errors and rectifying is called debugging. You need to find the error and you need to you need to correct that particular error. But look at this particular size, you don't know in which line or in which func service the error has been occurred. So it is difficult to maintain and it is difficult to debug also, okay. So that's why this particular Unix operating system is a monolithic operating system, and it is difficult to maintain and implement, okay. So next one is layered architecture. The problem with this monolithic architecture will be somewhat uh, overcome by this particular layered architecture. Here the functionalities will be well separated, okay. How? Because the operating system is broken into different number of layers, where the lowest layer will be your hardware and the highest layer will be your user interface. The user uses this particular user interface to access the hardware, but here you cannot access directly. There will be series of layers that has to travel, and finally it has to reach to hardware. So you can see the lowest layer will be hardware and the topmost layer will be user interface. And the remaining layers, suppose that layer 1 will be your device drivers, and this will be your CPU scheduling, and this will be your memory management, that is demand paging and etc. And this will be your IO layer, some particular layer will be your IO layer. All these are placed one above other, okay. So why we are using this particular structure? Because one, its structure, why? Because one, the major properties, the each upper layer invokes the lower level layer operations, that is each layer, okay, uses some function, it provides some functions and services to above layer, that is upper layer. So what layer 1 will do? Layer 1 will invoke as uses the services of layer 0. Layer 2 uses the services and functionalities provided by layer 1. So what we have to do, we must take care of this particular lower level layers first. So which one will be implemented first? The layer 0 will be implemented first. At the time of implementation, if there are any bugs or first, we need to clear all these bugs and move on to next layer, that is layer 1. Once layer 1 is bug free or error free and it is implemented correct, then only we will move on to layer 2. Okay. So if there are any errors, then we can easily find in that particular layer only. So because of we separated all the functionalities, if there is any error, we can go to that particular portion and we can find the error. So this structure will give you easy debugging, okay. And you can even add one more feature, that is you can add one more feature and one more service also easy. So construction of one layer, new layer is also easy, and you can easily verify the system, okay. So the construction is easy because the functionality is different, debugging is easy, system verification is also easy, and there is something called data hide. because the upper layer will use the services of only lower layers. So a layer does not need to know how those operations are implemented, that is lower level operations are implemented. Instead, it will only know what operation that has what, just knows what these operations do. That means what operation, that means, so if you want to access anything, you can open a file. So you could simply use open, okay, close, read, write, seek. If you know these things, the implementation will be written in the lower level layers, okay, right? So hence each layer hides its certain data structures that is used to implement it, and certain operations and certain services provide certain data that is used from higher level layers. So higher level layers doesn't see everything, okay, doesn't need to know everything, okay. So what is data hiding and etc, we will see in the coming units. The problem with layering: in the layered architecture, the biggest problem is where we need to place the layers. It is confirmed that the lower level layer will be hardware and top level layer will be your user interface. It is confirmed. But the problem is, what about the intermediate layers? Let's come to the scenario that the device, the hardware device must be at the lower level to your memory management layer. So if you take device drivers, because hardwares will be accessed by reverse layers, you have to be use memory management, because there are files that are stored in your hard disk that has to be copied to your RAM, that is your main memory, okay, main memory. So this has to happen. That means main memory have to access the file, load and store the file. So device drivers must layer must be below memory management layer. And sometimes the one more scenario is that the CPU scheduler would normally be below device driver, because sometimes programs will go for IO. Programs will go for IO, so that CPU will schedule that particular process later. How this particular CPU scheduling will be done, we will discuss in Unit 2. So it will be hardware, CPU scheduling, device driver, memory management, and other layers. But this is not the case always. This is not the case always. Sometimes what will happen, the CPU scheduler may have more information about all the active processes that fit in the main memory. Okay, so main memory, what is stored, all the processes are stored. Okay, so therefore the information may need to be swapped into main memory and swapped out of main memory. We'll discuss what is swapping in unit 4. Okay, swap in and swap out. So in order to perform this swap in and swap out, the CPU, okay, CPU scheduling should be above device driver. That means device driver comes down and followed by CPU scheduling and followed by main memory. So placing of these things will become a problem. Okay, so one more problem is that it is less efficient than non-layered approach. Okay, why it is less efficient? Because there are several layers are there, from starting from user interface, it has to come to hardware. Okay, so if you write anything, suppose that you have written a command or some particular program, that is f1 with one particular parameter, and while coming to next layer, that is n minus 1 layer, there will be one more parameter that will be added, x comma y. Then it comes to n minus 2, then one more parameter that will be added, maybe x comma y comma z. So there are several until it reaches to hardware. There are different parameters that will be added, and this will become an overhead. Okay, this will become an overhead as you keep on changing, moving from one layer to other layer. More number of parameters will be added, and the parameters will be modified, and data has to be passed from so one to other. So this will become a slower process compared to your non-layered architecture. Okay, so the performance will be decreased if we use layer